Hello all. In this session, we will see the projectile motion in the fifth module. So before going to problems, first we will see what is projectile motion and what are the things it will comes in the projectile motion. Then we will move to the problems. Projectile motion. The projectile motion is a motion in which an object is thrown near the Earth's surface and it moves along the curved path under the action of gravity only because of the gravity it is going to take a path, right? So here in the second figure you can see how the projectile takes place. The water fountain, it starts and it is going to end in the same place, that is in the earth, but it is taking a curve. Projectile motions, here you can see different projectile motions. That is, man is jumping from one place to another place, long jump. And the basketball, okay, is a basketball. When you're putting inside the basket, so it will be going in the curved path. Next one, the missile, or the missile or an aeroplane, how it will be launching from the one place to the another place with a curved path. And the last one, a fountain water, you can see how it will be starting and going to end to the earth's surface with the curved path. The motion of an object along it will take the parabolic path under the action of gravity, so that will be a projectile motion. So in the projectile motion you can see different paths. Here I have taken one path, that is here I'm mentioning v, that is velocity. So that angle contains theta, and the height of that the motion, that is curved path, it will be height will be h, that is the maximum point where I am going to explain in the next slide, that is how that vertical force is going to, vertical distance is going to mark. And the projectile, that is ball or a stone, anything, so that will be a projectile. And the range, that is r means from the initial point to the end point. So if you are throwing a stone from one point and when it is going to rest in another point, that distance will be range, that is capital R. Trajectory, okay, first one is trajectory. Here you can see only the projectile part. Projectile means the object which is you are throwing, that is a ball or a stone or whatever. Trajectory, the parabolic path followed by a projectile in the air is called as trajectory. So here trajectory is a path, just a path from one place to another place. When we are throwing anything, that path we are calling as a trajectory. Angle of projection, so how much angle we are throwing a ball or a stone. The angle with the horizontal at which an object is projected in air is called as angle of projection. Here it will be in any theta. Here you can see, so we are considering velocity of projection. So the velocity with which an object is projected in the air. So what is the velocity which we are throwing in the air? So that will be the velocity of the projectile. Next one, time of flight, that is the ball or a stone which we are throwing from one point to another point, how much time it is taking. If you are throwing any ball, so from one point to reach another point, how much time it is taking. So that will be the time taken. For example, any plane, it is taking a takeoff it is passing the trajectory path and going to end in some place. So how much time it is taking from initial to the final. So that will be the time of flight. Time taken with the projectile to cover the entire path, entire trajectory path. It is called as a time of flight. Maximum height of the projectile. So as I explained in the first slide, the maximum height when you are throwing a ball or a stone from one point to another point, we are calculating vertical height in the maximum point. We are going to calculate with a maximum point. It is a maximum vertical distance traveled by the projectile from the ground level under its motion. So we have to take the maximum part. For example, if it is coming from initial position to final position, we are taking that maximum portion. So that will be our maximum height of that projectile. Horizontal range of a projectile. So as I said, it is a horizontal distance. For example, if you're throwing a ball or a stone, you're throwing from one point and it's going to end with another point. So that first initial and the final point, that will be our range, that is horizontal range. That is a horizontal distance, we can call it as. It is horizontal distance traveled by the projectile during the entire motion. When the motion is completed, so we can calculate the horizontal range. So this is the end. Next one, we will go to the projectile problems. So the just go through the formulas for the projectile motion. We will see immediately the problems on the projectile. Thank you.